Okay. Okay. All right.
How was the AI week? I couldn't join because I said I was down.
Oh, it went very well. Lots of people came. Lots of presenters were there. So it went pretty well.
Yeah, I plan to look at those videos. Let's see.
Yeah. Quite a few people came. There was CTO of Capgemini, managing director of Lumen, and few more top tech leaders is what we aimed for, and it worked out well. So yeah. Okay. So where are we? How many of you have tried the sentiment analysis? Please raise your hand. I do not see the hands. There are only 19 people, including 2 of me. So total 17. One person? Only Veena? Who all have tried the sentiment analysis? Yes, has tried. Okay. Okay. Everyone? Are you stuck? Can I help? Help you? No. No. Okay. All right. All right. So there are a few things. Yeah. Everyone, before we start, do you have any questions for me so far? We have covered almost all of Python and say 50% of the data structures. And do you have any questions for me so far?
Sandeep, I attempted that project one, like celebrity lookalike one. It's based on the ResNet, right? If I'm not wrong. So
Yeah.
I need a little bit of clarity on that ResNet. How does that work? Today we can explain that. Okay.
It's essentially a neural network. Okay. And neural networks are basically sort of like mathematical operation which turn input into an output. Okay. And basically, how do you train a neural network? That's a separate issue. Okay. You basically create a loss function, like this is my error, and then you tweak the knobs. Okay. Think of, I'll talk about this more, don't worry. I'll talk about the neural network much more. And so far you can just think of it like a black box trained on a lot of data, and which basically gives us the results. Okay.
Yep. Okay.
And yeah, I want to, yeah, I'll focus a lot more now on the maths part of things. And right. So the flow of things is that now that we have covered most of Python, I can basically just give you an overview of how does the packages work in Python, and then we move, that's the only part that is left. Okay. So and I will give you an overview. Other than that, I think, is there any other doubt, like how is that working? No.
As I
So
mentioned, Sandeep, before, like the issues is not with the concept, but it's more about practicing and writing different codes now. So that's what I'm trying to do.
yeah,
Hold on.
let me see if you understood. So could you help me understand, or help everybody understand, how does the celebrity lookalike work? just give an overview of your understanding. I'll correct you, and or if anybody else wants to chime in, please put forth. If you want to show your code, it's completely okay. And or you want to, anybody wants to take the step to walk through the code of celebrity lookalike, I'll be more than happy to. So I think I can give you right away that walkthrough. I actually like it because it includes the chapter that we were talking about in Python. We were talking about scraping the data. There is a part there where we scrape the data in that notebook. It's a real use case, okay? And yeah, you guys should do some more fun stuff with Python. And one of the fun stuff is scraping data is like really fun. So once I needed like a lot of Bollywood songs, right? So what I did was I downloaded a website called songs.pk, right? If you guys have known. Okay, so I crawled the entire website, downloaded the music, and then rearranged all the music in proper folders and updated their MP3 tags. Everything could be done in Unix shell script and Python combined together. Okay, so that's a power of Python. So let me, do you have, what do you call it? Lookalike celebrity. Look-alike celeb. Yeah, celebrity look-alike face record. Oh, star by face. Somebody has published it. Okay. Oh, okay. Who is my celebrity look-alike? Oh, nice. It has become. Okay. Okay.
Sandeep, you're not sharing if you are intending to
Okay.
share.
Oh, sorry. So I'm just trying to see where is this repo? Look-alike celeb. Yeah. This one, right? This is that this is that project. Okay, I'll just clone it in my in Jupyter Notebook. Okay, I'll just log into my CloudxLab environment, and then I would be showing you this. This is important, very important for everyone. Okay. Why it's not working? Yeah, it's working now. Okay. Okay, I'm going to say git clone. All right. All right, git status. Okay, perfect, perfect. I think I already have a most updated version of it. Okay, see if you guys don't have this repository, probably you can just take a look at this. Now, right, let me walk you through the code. Or if anybody else wants to walk through the code, that I'll be more than happy to talk about that. I mean, I'll be more than happy to let you share the screen. Okay. This is the lookalike celebrity. What? Yeah, yeah. So in this is one notebook. Okay. This is one notebook. Find similar actor dot I by NB, right? So this is the main code. Okay. And basically that's the thing. Now here is an important piece of code. Okay, download images.py. Okay, I want you, this is basically related to scraping the data from the web network programming. Okay. So coming back to it, let's go back here. Okay. So this is the script that I used to download the things from imdb.com. Okay. So I use a web package called Beautiful Soup. Beautiful Soup. Beautiful Soup is a library to clean up the HTML, because when inside a web page, the Beautiful Soup is in a web page, the HTML usually is very dirty and unclean. So and you need to parse it and understand it. Beautiful Soup loads the HTML and gives you a way to interact with it using Python. Okay. So you can, let's say this is your HTML, okay, and you want to, let's say, find out how many classes are there with the class sister in this, or find out all the paragraphs with the class story. Okay, so what you usually do is you load this HTML using Beautiful Soup. You get this soup as an object, and now you can interact with it. Like, for example, if you say soup.prettify, it will make your HTML pretty and print it. And then if you want to extract each value, let's say soup.title will give you the title of the website. Then title.name will give you the title. I mean, this tag. And then title.string, it'll give you this value. So you can interact and you can extract the value from the page. You don't need to write the parser by yourself. This is the parser. Okay. Beautiful Soup is the parser. So inside the page, if you want to find p tags, you can just say soup.p and it'll give you a list of those things. Okay. Like, for example, soup.a would give you this link. If you say soup.findAll, it'll give you all the hyperlinks. And then you can also say soup.find this. So you can get particular link where ID is equal to link 3. Okay. So basically you can basically parse and extract the information from web page using the Beautiful Soup. You can simply install it using apt-get install, and that's about it. Is everybody on the same page so far? Yes? No?
Yes.
Yes.
Okay. Feel free to stop me right now. Do you want me
This
to
is for
explain?
downloading the images, right? Like
No, downloading the HTML and extracting information from HTML.
information. Okay.
Okay. So it's the predominant package for interacting with HTML. Okay, it helps you interact with the HTML. Okay, at the same time, if you want to automate the browser things, you can take a look at Selenium Python interface. Okay, you can take a look at Selenium Python interface, where you can basically code everything in Python and just load in things in the browser. Okay, in the browser, and then you can do all kinds of things. So all kinds of automation. So you can just say, launch the Chrome browser, load a web page, take the screenshot. So browser automation you can do with this Selenium with Python. Okay, so those are few things to keep in mind. I will, where is our notebook, our usual notebook? All right, let me also open our usual notebook. Okay, so this is our, okay, this is our here. Okay, what's the date today? Today is August 9. Okay. All right. So there we are. So this is one package that we talked about for browser automation. Okay. For browser automation. Okay. And for parsing and loading HTML, we talked about Beautiful Soup. Okay. And right. Perfect. I'll just keep making notes of this and right. And we also are going through the, what was that name of repository? Okay. Look alike celebrity. Okay. So this is these are the references that we're talking today. And now coming back to this. Okay. So what we are trying to do is we are downloading, getting all the celebrities. So I wanted to download the photos of all the celebrities. Okay. Right. Okay. So here, most popular celebrities, I went to this page. Okay. And instead of this, what I did was, okay. Nah, not this one. Let me go back here. Let's just copy this. So I basically found out that, okay. Yeah, top 1,000 actors and actresses. Okay. So basically just went for top 1,000 actors and actresses. And then what I did was I wanted to download these photos of people. Okay. So what I did was I went here, did inspect element. Okay. And looked at what's going on here. So this looks like a hyperlink. Inside that is the image of the person, most likely. Okay. So I basically went through the inspect element, try to find the image of the person. Okay. And how do I, yeah. So here we are. Okay. So basically, once I figured that out, that okay, what's the structure of the page, then I came here. I said, okay, get this, first of all, get this whole page. Okay. Now I basically use URL lib request.url retrieve to download the page. Okay. So once I downloaded that page, I got the HTML from it. Okay. Not this one, request.get URL, not this one. This one, download HTML, it basically gets me the HTML. So I got the HTML of this page, this particular whole page, I got the HTML. And then what I did was I wrote this function called get actors from the HTML. Okay, get actors from the HTML. I pass here the full HTML document. I load it to using Beautiful Soup, and here's the object of the soup. And then I say, okay, find all this. I passed a method that basically checked against every node. And here what I'm checking is if the tag has attribute called class and this particular name exists in the attributes. Okay, so I find all those the tags that have this one. Okay, let's take a look. So, okay, is this the one? No. Let's see. Where is my code? It says lister dash item image. Okay. Looks like they have changed the page. Have they changed the page?
Sandeep, are we referring the right project here? Sorry to interrupt here, but can you look into the project in the course, under the course and the project details?
Yeah. So you must be seeing only this part.
Yes.
Correct? Yes.
Yeah.
Right? Here, what I'm talking about, where did we get the data to match your photo with?
Okay. So here it's
We are downloading the photos of all the actors.
okay.
So the
But
plan
where are
is,
then we importing in the package? Like,
what?
can you go back to the main code?
Yes, I'll show you. So here we downloaded all the photos of the actors into a folder. Where is that folder? Somewhere I had downloaded those things. Okay. So I basically, you can see here, I keep on downloading the photos of all these actors into images folder. Okay. So if you go to images, you will see the photos of all the actors.
Yep. And Sandeep, go to that Salab lookalike, the main code there actually.
This one, right? Here.
Yep. So where we are calling that? Where are we calling that?
So you can see here. First of all, we are loading all the images from this folder. Okay.
Yep.
We say face recognition, load image file. It loads and then we convert this image into encoding. Okay.
But then where the main file has been called out actually, like the other Python where using which you are downloading it up. That's the reference.
That is not called directly. That one is only used to prepare this directory.
Okay.
So this one is only for gathering the photos of all the actors. So we got all the actors, 1,000 actors, and we got your photo, and we'll just try to compare which actor is closest to you.
Okay. Yeah.
Okay. So this script is basically downloading all the actors' photos and their name and saving it in a file.
Okay.
Okay. So the name of the actor is the name of the file, .jpg, and that's how it infers that. So we basically here, you can see known images directory, we are going through file by file and then doing it. Got it? So first, what we did was we downloaded all the actors in a folder by scraping the data. You can see download images.py. If you want to understand more, go through this one, try debugging it, try running it again, and do it slowly. Okay.
Okay. That's where I was confused. Yeah. I'll give a try again. Yep.
Yeah. Now comes the machine learning part. Now we got all the actors, their images. Now we want to find out who looks like me. Okay. So we import the usual library. This is the ML model. The moment you say import face recognition, it's going to download the neural network model for face recognition.
Yeah.
Okay. And then I'm importing OS, which is needed for files and folders, and then NumPy. NumPy is that efficient Python list. An image is a package which displays the image and provides you all the functionalities for image. Okay. Now, the next line here is, we are saying P1 is an array. Okay. P2 is an array. Okay. P1 contains 1, 2, 3, 5, 5. P2 contains 3, 4, 5, 5, right? So if we want to do P1 minus P2, what will we get?
Right. Distance, basically.
Yeah. So let's take a look. So if we have, I imported all of them. Now I defined P1 and P2. Let's take a look. How does P1 looks like and how does P2 looks like? Now P1 minus P2. Okay, so this is the one.
Sandeep, sorry, just maybe a basic question. This face recognition is also a standard package?
This is basically a kind of a package made available by the open source community. It's basically a big neural network which when run, you will be running that in your notebook. Okay.
Okay.
It's not an API call to somebody. It's downloading a model to your notebook. Okay. It won't cost you anything. You don't have to provide any key or anything. Okay. Now P1 minus P2, what it did? 1 minus 2, 2 minus 4, 3 minus 5, 5 minus 5, 5 minus 7. Okay. That's what we get. Okay. Then when we say np.square, what does it do? It takes this value. Okay. And np.square, let's just see what is there. Okay. It is squared all the values. Okay. So, and then if you say, right, if you want to find the other distance, L1 distance, Manhattan distance, what it does is it first computes the absolute value, meaning -2 becomes 2, like that. And then when we say sum, it basically sums it up. Got it? And now the dot product, you can simply say np dot a comma b. Okay, so that's it. So this one is a L2 distance. This one is a L2 distance, L2 or Euclidean distance. Okay, and this one is a cosine distance, right? This one is a cosine distance. And this one is a L1 distance or Manhattan distance. Manhattan. It's not a distance, it's a similarity. Okay, that's what is displayed in this example. Okay, then there are ranking systems, logistic one, entropy, cross entropy, Hamming distance. There are many more distances out there. Okay, but these are the three kind of things that you will see more. Now we have P1, P2, and now we can do a square, and this is how we can compute the square distance, mean square distance, square distance essentially. Now, okay, so yes, you can just import math and do math.square, sqrt, and that's it. Now comes the next part. We are defining a function to load images from this directory. Okay, it not only loads images, but it converts them into embeddings also. So what it does is for file in this directory, for each file in this directory is going to basically decode the file, as in load the file into this object, and then sorry, it gets the file name from this one, and then it asks a face recognition model to load the image file. Again, right now it's not running the neural network. This is where it runs the neural network. Face encoding converts this image into bunch of numbers. Okay, it converts it into bunch of numbers, and then for each of these face encodings, what it does is known encode. It basically appends the encoding. It appends the encoding and it appends the file name. Okay, so file name is your actor name. This is the encoding of that one. Okay, so you got two arrays. One is called known encoding, other is called known images. These two arrays is what it returns at the end of the process. It goes through the whole folder, prepares the encoding, prepares the name of the images, and that's it. Okay, so encoding and the names. Okay, now we wrote this function simply called calculate distance, the encoding of all the encoding that we've known to us, that is like all 1,000 actors, and this is your image file, and then we are defining the cutoff. Okay, and we are saying give me 4 results. Okay, those are the arguments. Now what we do here is we ask face recognition library to load your image. We got the image. Then we calculated the encoding of your image, okay, that we are trying to find out for who we are trying to find out the celebrity lookalike. And then we take this encoding and then we are asking face recognition itself that can you find out the distance, phase distance between this and right? These are known encodings, and this is your photos encodings, and it returns this distance of your photo from every photo that is there. And then what we do is we say, okay, give me argmin. What does the argmin do? It gives the basically the smallest distance. If I say, okay, let's say 1, 2, -1, 3, -4, right? And I say np.argmin, okay? So what does it do? Okay, so it is returning 4. What is 4? What is the smallest value in this? -4, correct? So it goes through 0, 1, 2, 3, 4. Okay. And if let's say we have -20 here, now which element is minimum? This one. What is the index of that one? 0, 1, 2, 3, 4, 5. This is the index. This is the 5th element in the, it's a 6th element, so which means index is 5 because it starts from 0. Okay. Everybody okay so far? So argmin gives us the smallest distance known to us. And that's it. And basically, once we get the argument of that one, index of it, then we basically pick the name of that and return it. That's it. Okay, let's do that. Okay. So this is the original image, Pranay, and the image file is this. Okay. It's trying to load the image. For some reason, this one basically just thinks that everybody is Mohanlal. Okay. Okay, so now is the magic is starting. It's basically first loading the images, then it's going to find the closest.
Actually, Sandeep, I tried in the CloudxLab, it is already available, right? All the images are already available. I tried to repeat the same thing in my local, but I don't have the collection of these images. I tried to download it through WinSCP, but it was not possible to download it from
Is it?
CloudxLab. Yeah, I was not able to download it from the CloudxLab, but it's
No,
on
why
the
don't
root
you
directory, right?
download? Isn't it available in this one? In Git?
In the LMS, it is, we are taking it from cloud/CXLlab/images.
Copy that folder to your home directory and then just zip it and download it.
Okay. No,
Okay.
maybe I'll try this method of scraping so that I'll get a glimpse of what scraping is like. I'll do that.
Because that dark art of face scraping is something that everybody should master. Google became Google because they could scrape the entire world. Okay. Facebook, those who don't know, you should know that Facebook crawled lots of internet. And similarly, when you think of Amazon, right, what they usually do is they keep an eye on all the brands, like camera brands and everybody. So we keep on crawling everyone's website just to check if they have a new product. Okay. So crawling is and LinkedIn actually crawled many websites to just to find out the leaders and workers in every company and just keep on creating their fake profiles and then messaging them that would you like to claim your profile. That's how they did the seeding of the profiles. Okay. So that's why the dark art of scraping is the secret behind the success of most of the Silicon Valley companies. Okay, those who believe that the world is like a straight, that I'll create the best product and everybody would start using. No, it doesn't happen that way. Okay, in case of Facebook, initially they crawled lots and lots and lots and lots of data and made, like, by hook and crook, they essentially got the users to use. Okay. And yes, initially it takes very different approach to basically do that. Like, for example, Facebook downloaded all the phone book of Gmail. Similarly, LinkedIn downloaded the phone book of Gmail. So yeah, so all of those hacks, all of those things are called growth hacks, and people, I mean, the companies who successfully execute those are successful. Okay, so learn the art of automating, learn the art of scraping, and yeah. All right. Any questions on this? I hope this one is now clear to everybody. We downloaded all the images from IMDb by we went to page by page. If you see here in this code, we went page by page. Okay, you can see I'm going through the 10 pages. Okay, so like I realize that there are 10 pages and I'm making a call to this URL 10 times, downloading from each of the page, I'm extracting all the images of actors and then going to the next page, then keep on doing that over and over. So yeah. And sometimes when the browsers don't allow you doing that, you automate it using the Chrome drivers. Okay. We call them Chrome driver, or you can say Selenium driver. Okay. All right. I hope this makes sense to everyone. Are we stuck? No? All right. Let's see. Okay. Let's see. Yeah. For him, it's Mohanlal. And for me, I don't know. Okay. Let's see.
For you, it was Prakash Raj. I remember.
I see. It has a very weird logic. Okay. If I don't like the actor that I'm matching with, I would blame that machine learning model. Okay. This guy. Yeah. This guy. Okay. You'll be surprised to know that I did look like that. Even my glasses were like that. Except for the lipstick part. Okay. Interesting. I never knew that such actor actually existed. Okay. All right. So yes, to some extent, it is good. And also you guys can try some newer model. This one, FaceNet, is a little older model. So you can take a look at the various open source models available right now. Try those. Okay.
Yep.
So that basically gives you two superpowers. One is a language, handling the language by using the language embedding. And second is handling the faces or face recognition systems by using the face embedding. Okay. The third superpower I talked about is being able to crawl the internet. And right, with this kind of tool in your arsenal, you can do a lot. Okay. And
I think I need to go back to the drawing board again and to understand this, how the images and beautiful. So I think the main code was not
okay.
difficult to, but yeah, need to understand the backend logic of scraping the images and other things.
Yeah, do that. It took me, say, a couple of days to get it done. Okay, probably like 2-3 days, and I think it would require your attention. It requires, okay, and yeah, just make yourself super comfortable with these ideas. Okay, and moreover, once you know what's possible, what's not, what you can do is you can actually just use ChatGPT or something to generate most of this code.
Most of
Yeah. Okay. More important idea is that we convert face into a bunch of numbers, and then we compare these numbers using that distance, and the ones that are closest, they actually look similar. Okay, that is first idea. Similarly, what we talked about is sentiment analysis, that we convert the whole text into a bunch of numbers, and then we compare that with these bunch of numbers. We find the distance with another one, and then we basically can see that the meaning, semantic meaning of text is similar for close by numbers. Okay, so those are powerful ideas. Those are very powerful ideas that once we have represented something with meaningful numbers or semantic numbers, then we can do a lot of magic. Okay? Make sense to all of you? All right, perfect. Now with that, I want to formally start. Shall I go over the modules and packages? Is everybody okay with modules and packages? This is
We can.
okay. I've just renamed it.
Sandeep, are you sharing any screen?
Why do I keep on sharing? I do not understand. Okay.
Yeah.
Modules and packages. Okay. Yeah. Here is a pretty simple thing. Okay. I want to use the console today for addressing this. Okay. Okay. Let's see. Okay. I will just use the console today, and I will go to the terminal. Okay. And I'll go to the terminal. Okay. And I'm in this folder, our folder called this one. Okay. I'm creating a folder called modules experiments. Okay. I'm in this folder. Okay. Right now, this is my current folder. Okay. At the end of the session, I'll commit this code to keep clarity on this. Okay. So my present working directory is this, and my list of files are these. Nothing is there. Dot means current directory, dot means one directory above. Okay. Now, coming back to it, let's create a file. So usually what we have done is we understand that if we have, let's say, right, we basically want, if we want to use a function, we just define a function. Okay, which one you are comfortable with? Should I use the VI, or should I use this one? Okay, let's say this one. And new text file. Okay, let's say we have this program. Okay, we have this program called Fibonacci. Fib. It takes n. And what it does is it basically generates the Fibonacci series up to n. Okay, how does it work? Initially, the two numbers are 0 and 1. Two numbers are 0 and 1. Okay, 0, 0, and 1. And then what we do is we say, okay, the first number will become the okay. So what we do is we basically say, right, the B will become, the second number B will become A plus B. 0 plus 1 is 1, then 1 plus 1, 2, and then 2 plus 1, 3, 3 plus 2, 5, then 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21. Okay, so it's kind of increasing, right? So it's basically kind of increasing exponentially. Okay, now let's say we defined this and we tested if it is working or not, right? So, and we call this, let's say, my lib.py. Okay, that's the name of my program. Now, once I do that, I can essentially just use it. Let me show you. I saved it. Okay, I saved it. Now I go to the terminal. Start, say Python. If I do Python just like this, it will launch Python 2, which I don't want. So I would export the path to my current one. Okay, so this is the path. Now I'll just put this into the notes here so that you guys can, you know, where is my notebook? I closed it. Oh man, don't tell me. Okay. All right. Yeah. So this is the one, right? I'll just keep it open. Okay. And okay, this was way to set the path. All right. Okay. For launching Python from Python 3 from console. Okay. First execute this. And then just say Python. Okay. So yes.
Sorry, Sandeep, why do we need to add it in path? If you install Python, it automatically should be added to your path, right?
No,
You just need to change the environment.
Yeah, I have not added in the path because that interferes with default Python version for Spark. Okay. The Spark by default needed Python 2. That's why we have not touched it because it is started. The newer versions of Spark are okay, but older versions of Spark start breaking. So we have to maintain all the versions of Spark. That's why we are keeping the default one to Python 2. Okay.
Can't we control that using environment?
Yeah, you can definitely
We can
control that.
create an environment where we can change the Python's.
Correct.
Right? Okay. Okay.
So once I do that, once I exported it, now if you create an environment, it will automatically pick the Python 3 next time when you activate the environment.
Got it.
Oh,
okay.
Correct. That's the right way to do it. Now, let's say here we are. Sorry. Here we are. Now we can simply say import mylib. Okay. It says now that there is something missing here. Let's go back where is that file? It says there's something missing. You see, it's a Python 2 code. So I'm just saving it again. And let's go back here. Terminal. And then again import mylib. This time it has imported that lib successfully. Now I can say mylib. But what was the name of the method? Name of the method was fib. So fib and I'm saying 10. So it has 0, it started from 1, 0 doesn't include 0, 1, 1, 2, 3, 5, 8. You see that? So it has printed the Fibonacci series up to 8, this time up to 100. The moment it goes beyond 100, it just stops. Okay. So you can see that it is kind of exponentially rising, correct? So every time I'm adding zeros, it's just increasing numbers by a couple of them. Okay, is everybody okay?
Sandeep, sorry, can you go to the directory? Did you create any other additional file in that directory?
No,
Like,
no. All I did was, so if your file name is mylib.py, okay, just import mylib. That's all. Import mylib.
okay, got it.
If your file
Yeah,
name,
sorry, I got
if you,
confused. I sort of assumed you created mylib as a package. Sorry, my bad.
if you,
Got it.
if your basically if your file name is this mymathlib.py, then you do the import mymathlib. Okay. This is called the module.
So
Okay.
in this Python file, Sandeep, we can have multiple functions, right?
Correct.
And then
Correct.
okay.
You
So
can call
suppose
them.
there were okay. So
You can
dot
just
fib.
say,
Okay. Got it. You
you
had
can say
invoked the
import.
function as well.
Yeah. Let's say here, and we are saying mymathlib.fibonacci, and okay, that's it. Now let's say you have one more function. For example, this one. Let's say there is a factorial function. Okay, what factorial does is it basically computes factorial. I'm going to just fix the tab. You can see there's a extra tab. Okay, so here we are saying if n is less than equal to 0, return 1. Otherwise, return n, this is wrong, n times factorial of n minus 1. Okay, and that's about it. So now if I import again, import mymathlib, okay, and then I can say mymathlib.factorial, okay. So it doesn't have factorial method. Okay, probably the reason could be that the module is already loaded. So I exited the Python and then again imported. You can see that's about it. Okay, so you can use both the functions. Okay, you can say Fibonacci this and factorial that. Cool, everybody okay so far? And if you are sick of just typing this big name, what you can do is from, okay, you can say import start. Now you got factorial normally, and that's it. So all the functions just came into your workspace, and then now you can use them without having to prefix the module name. Okay. Is everyone okay with so far the module packages? So you just created the module. Okay, very simple. Just create a file, put it in the Python path, and then start using it. Okay. Now let's say here right now you are in this folder, correct? In the current folder. Okay, and you put it inside. You put it inside. Let's say src. You created a directory src, moved my mathlib into src. Okay, and now you want to do you want to create a file called test.py here at this level. So src folder contains your library, and inside that, let's say there is, you created a folder called test. Okay, here I'm creating a folder called test. Okay. Why it is to be, okay. And inside the test, you want to create another program. Okay. Not this. Sorry. Okay. New text file. Okay. New text file. Okay. I'm calling it main test.py. Okay. Here we are saying from my Matplotlib, whatever code we had written here, okay, we will just write it there. Okay, my main test. And I am saying, what else we did there? Let's just go back. We said, okay, compute the factorial, compute the Fibonacci, and then, okay. Okay, now let's see, does it work? All right. Okay, so we have two folders here. Okay, this is the module experiment folder, parent folder. It has got src. Src contains our library, and then we got test. Test contains the test cases. Okay, let's try to run the test cases. Okay, test cases basically do this. Now, okay, let me clear the screen. So present working directory is module experiments. We went, and it has two folders, src and test. Ignore this particular folder. Whenever we are importing a module, this one gets automatically created. Okay, it keeps the cache of the module. Okay, so sometimes what happens is if this is not changing, sometimes what happens is that you might have to delete this cache if the module is not reloading and it's just loading from the cache. You might have to delete this. Okay, now let's start with test. Went to the test. Okay, and then in the test, what we did was, let's say we are saying Python main test. It says no module name mymathlib. Okay, so what we would do, we'll say Python. Okay, let's find out. Okay, this is the folder that contains my code, correct? So we'll say export Python path equals this dollar Python. Okay, now let's see. It still says this. Okay, export Python. Wait, does it only Python path? Okay. Let's see, does it work this way? It still says that this is not, oh, sorry. This is supposed to be Python path. This is supposed to be src. Okay. Now it worked. Okay. So you have to define a variable called export Python path, and that would work. Okay. And yeah. So, and further, what you can do is you can say here, where is my file? Here you could say import os dot environment variable, and you could say, okay, set Python path using Python code. Okay, so not here. There is a programmatic way of doing it. Well, let's say for now we can do something else. Okay, and I would say here. Okay, Okay, I'll just copy paste here. I just want to show you, I just want to document it so that you don't have a problem in finding this. Okay, so here we are. So for a demonstration, we can also do this. Okay, we are basically exporting it. And let's see, does it work now? Okay.
Sandeep, this $Python path is set inside, it's a variable inside the path,
Which one?
environment. The Python path, you exported the Python path, not the path, right? So
Correct.
Python path is a variable inside the path that you're referring? It's inside your path.
So let me just go back to the terminal. Right. So here, this variable is a variable where Python looks for the modules. Okay.
Okay. Okay.
This is the variable where it goes, just like Unix commands look for the commands in path, Python looks for the modules inside Python path.
But then, Sandeep, after source, what did we do? $Python path. What does that mean?
Does it mean whatever was the old path will come here? So it's like appending.
You are appending it. Oh, okay.
Yeah.
And then any Python file in the source directory will be added here, right? I mean, then it will be imported. So just not like in our case, we only have one, but if we had multiple Python files, then everything will be imported.
If you have multiple files there, it will be imported. Okay. Not inside that folders, and so on. Just at the top level.
Just that folder.
Yeah. Okay. So far, everyone okay? Right? All right. Okay. So with this, you can essentially interact with modules, organize them. Further, there is, right? Okay. Now the thing is, whenever you are importing a module, the print statement and other things will also get executed. For example, let me go back here. Let's say what you were doing here is print, okay, testing 1, 2, 3. Okay, let's say this was there in your modules, correct? So what would happen is if you basically, so if you, okay, it just, okay, running it again and again. Okay, so let me go back and delete the cache. Okay. Oh, it saved again here. Okay, I'll delete this. All right, I'll close. Okay, I'll close it from here. I will go back here, go to, I'll delete from here, okay? So that there's no confusion. All right. Let me go to SRC, and this is where your files are. Okay, now let's say in your module, you had written some testing code. Okay, now the moment you import it, what would happen is, okay, you'll say import. What's the name of the file? My Matplotlib. Okay, so the moment you did the import, everything in this file got executed, right? So you can see this last line, line number 11, also got executed, right? Because of this, it's kind of becomes messy. So if you have to write your code inside this path, inside this file, what you can do is you can say if name equals like this. Okay, so this sort of a magic one, you can just write like this. Okay, so now
What does that mean, Sandeep?
it means that if you call it directly, then this code will be executed. If you import this, then it won't be executed. Let me show you. Okay, let's go back here. Where was that? Here, right? So if I go to Python and say import my Matplotlib, this time it imported but did not execute this line. Okay, did not execute this line. Earlier it did. Okay, because when you're importing, the name of the caller is not main. Okay. Now, if you run this file, if you go to that folder, what was that folder name? SRC, and you go to that, right? You go to this folder and run this program, Python mymathlib, then this line will be executed. So if you basically here, if you import this module, then this line won't be executed. If you run this directly, then this will be executed. That's the difference.
But Sandeep, we have to import it first, na, before executing.
No, this one is like, sometimes what happens is, let's say you're building module and you want to test the module then and there. Okay. So in those cases, all the testing code you can write inside the main and then use it. You can essentially use it like this also, right? Testing, and you say, okay, Fibonacci 10. That also can you use, right? You can basically use the module. Got it? So test it.
Okay.
All right.
But Sandeep, like, so this is like, if I have this mymathlib.py, right, the Python file, and now I want to use these function in another Python file that I am writing. Means I think the like how we do it in Java, right? So you import the packages. So the same thing we can do it here. Maybe it's
that's what we did. We basically said import from mymathlib import star.
Okay.
And that's what we did. Okay.
Okay, got it.
We use those functions.
Okay.
Got it?
Yeah, I haven't practiced much in Python. Actually, hardly anything. So that's I get confused.
Okay. No, you should practice. This is right, the easiest thing. If you're coming from Java, you will absolutely love it. And you will you'll have that spark you will start loving the code in general. Okay. So yes. Perfect. Now let's Okay, so I hope everybody's clear about it. Okay. Now, in case you have, let's say, right, this we talked about. Okay. We talked about this. Now the next very important thing comes into play. We call that packages. Okay. Packages like such as A.B.C.E, that kind of packages, right? Let's say this is my file. Okay. Now I basically, if I want to basically create some sort of a folder for these. Okay. Let's say I will remove the lib from this. Okay. And I want to have a little bit more structure to it. I'll create one more folder here. Okay. Let's say lib. Okay. And I move it from here to lib. Okay. And now inside SRC, inside lib, I have this. Okay. Now, in order to use this kind of a structure, okay, So we have lib, okay? And we might want to put some more things like core, okay? I have, let's say here, I created one more folder called core, okay? Let's say core, okay? And inside core, I have, let's say, simple code, okay? What it does is, right? In core, we have, let's say, main.py, okay? And inside the main, we have, let's say, function called hello, okay? Inside the main. And all it does is it just prints hello, okay? So now what I want you to see is, oh, sorry, I messed up. I was supposed to create main.py text, not the Python. So not the notebook. I was supposed to do this. All right. Now this is my program. Let's take a look. Deleting it. Okay. So we have core, we have lib. Okay. We have core, we have lib. Okay. Now, how would we use such kind of a code? Okay. It will become all the time messy. Okay. It'll kind of, how would I use this? Okay. So in this case, what we call them is, we call them packages. And to make it look packages, all we got to do is inside all these folders, just create init inside all. Okay. Inside all of them, I just create an empty file called init.py. Okay. So here I'm going to src. Inside core, inside lib, I'll basically just put the, okay. So inside core, this is my src, right? This is my src. So here I would just say touch init.py. This is an empty file I created. Okay. Empty file I created here. And then similarly, I also would create the empty file for core. Okay. So I'll just say touch. Okay. Similarly, I will say here, I would do touch. Now, I go back. So inside the src folder, or let's say module, if I show you the folder, so at the top level, we have inside src. Okay, let's say here. Okay, this is where my code resides. Okay, and if you take a look at the find, so what you have is at the top level, you have init.py, core, lib, inside core again init.py, and that's about it, right? How do you display the file tree? Okay, what was that, right? How does it really work? Tree does not work anymore, right? Or tree does not work. Anyway, so so you got the picture, right? If you see core ls core, inside that also we have created init.py, and ls lib we have created init.py. Now, in our testing code, right now we create the full folder structure. If you go back here somewhere, you'll see that inside src init.py core lib, inside core our module and init.py, and inside lib init.py my math, right? So now with this init.py, Python understands what to do, right? It would start considering it as a package. Okay, it would start considering it like a package, and then if you go to, let's say, my math, and where is, I'll just close this. Okay, again, come here and open my math. Okay, and then go back to, let's say, core would be okay. We have already this one, and then we have lib. Sorry, I've already opened it. Go back here. Let's take a look at the test now. Okay. Now in the test, we can't use this because it will throw error that there is no package. Okay. So I'm going to test now. Let's try running the test. It says that no module called mymathlib. Okay. So now go back here. From now we can say things like from core.mymathlib import star. Okay. And then that's it. It still says the mymat, right, is not found. So okay, let's see. Does it require me to say src? Let's see. Okay. Should not be, right? No. Oh no, it's not in code. I'm sorry. It's not in code. It was some other name, right? What was the name? It was in
lib.
lib.mymath. Lib.mymath. Lib. Okay. So lib.mymath, and let's see, did it work? Yes. Got it. So all I have to do is say from lib.mymath import star. That's it. So you can create your folder structure, just put everywhere empty file called init.py, and that's it. And then you can start using it.
So if there was another subfolder under my math, then
yes.
there
Again,
also we have to put init _.py.
Yes. That's all. So you can create any complex structure, put empty file, and that's it. And then start using it.
Is this init file always empty? It's mandatory that it should be empty?
No. Init file is reserved for cases like when you are importing a module or a package, what to do at that point of time, if there's a preparation needed before that. Okay. So for initializing a module, you can write Python code into the init.py. Okay. But it's mandatory to have the init.py. It is okay not to have any code inside it, but it's a signal that this is a package. That's it. So imagine that you're working on a large project, say sound package. So sound, inside sound, there'll be init and then packages, formats, this and that, and like that. So when you are importing the any packages inside Python, they must have created their folder structure like that. Okay. Okay. All right. Okay. There are quite a few useful packages. Those who are interested in game development, they can take a look at the Pygame and they can use that. Okay. All right.
Sandeep, one quick question. I mean, once we create a package, right, how do we, is there a process to put them in the centralized directory where we can allow people to do pip install?
Yeah. So you have to publish it to PyPy. PyPy. Okay. So you have to publish it to PyPy. Okay. So take a look at how to publish on PyPy, and then people can just use it directly from this repository. Okay. Pip essentially looks at a particular variable to find which repository URL to use, and then it installs. Okay. So if you want to create your own package, just learn about how to do it. I'll just show you how to do it in my code recently, the one that I did. Okay. All right. Where is it? I'm removing this. Okay. So take a look at this one. How do you? Yeah. Okay. Okay. So once you basically can update using the twine, you can upload this. Also, you can use a module like this also. Okay. You can essentially just use the module like this. Okay. Python-n, and that's it. Okay. You can do that. Okay. So that's pretty much. And yeah. You can publish your work like that. Okay. So so far everything is okay. Everybody okay so far with the packages and modules?
Yes.
Modules are nothing but one single file. Packages are nothing but folders. Okay. And there are quite a few useful Python packages out there. One is Pygame for game development, PyGTK, that's for GTK toolkit, and then Matplotlib, NumPy, SciPy, Django, Beautiful Soup, Pandas, and for almost everything, there is one Python package. Okay, like movie.py that essentially helps you editing, modifying the movies, and so on.
Hey Sandeep, here one question. This Django is a framework, not the Python package, I think.
It's essentially a framework which comes as a Python package. You can do pip install of the same thing.
Pip install. Yeah.
Okay.
But what is the difference between the package and the framework? Like the Django have the multiple inside more packages.
Everything is a package, right? NumPy, Panda, everything comes as a package. Now people start calling something as a framework, something as a library. Okay. Framework is something that contains a lot more things than a simple small library. It's an extensive suite of things. Okay.
And if you wanted to understand what exactly the package itself,
What?
if you would like to know, like NumPy, the package, what exactly the program they have written, can we do that?
Yeah. Source code is available for each and everything. All of these things are open source. The only problem is that some of these modules are basically written in C++. Say, for example, NumPy is written in C++. Okay, for performance reasons. Okay.
Got it.
So you can take a look at the source code and you'll be able to understand what's going on. Okay. You can interact using Python with many binaries of C, C++. You can create the bindings and work with them. Okay. All right. So I hope this made sense to all of you. And any questions on this so far? No?
Sandeep, here one question. Like we are written the packages, like multiple packages. How to, like, I don't want to transfer the source code to the like the client or the another user. How to provide the code as the byte or zipping in the Python? Like in the Java, we have bin file or something different
In
file. Yeah.
Python you don't. There are some obfuscation libraries, right? Python obfuscation libraries. Okay, so take a look at some of the Python obfuscators that tries to obfuscate the file. Okay, and that kind of makes it unreadable. Okay. And
we provide the source code, so anyone easily update the my source code and use for the further modification. But
That's the concept of open source, right? Contribute.
yeah. Okay. So there are these tools that help you merge the packages into one. Okay. And that you can use so that it becomes like unreadable. Okay. All right. Basically, these are kind of open source kind of libraries. You have to provide source code. There's no other way. Okay.
Sandeep, can you share this link to the chat, this URL, basically jupyter.eCloud here in the chat?
Which one? This one?
Yep, yeah.
Oh, you won't be able to use it. I will have to commit the code.
Okay.
Okay, I'll just commit the code. All right. Git status and August 9 and module experiments. And that's about it. Git commit. Okay. Classwork. Git push. All right. I have uploaded. So now you can download GitHub. Okay.
Yeah. April 24th, right? Yeah.
one more question here. Like
Yes.
Python have the multiple, like the C Python, Python, but we are using this data analytics part or the ML part. Which compiler is good, or we can say which interpreter is good for the further?
C Python is for basically compiling C code. Okay.
If any source code in the this ML part in the C++, then we use C Python. That is better.
Yeah. I think we use C Python or something.
Like Python, pip install maybe the Python.
Okay. I have to look into it. Which one do we use? Okay. Yeah. All right. Okay. Basically, under the hood, Python is implemented in C. Okay. Unlike the C libraries or C++, where C++ is written in C++. Okay.
Yeah.
And here the Python is written in other language. That's the only awkward part about it. Okay. All right. I hope it made sense to everyone. Okay, let's move ahead. Yeah. Where are we? Okay, let's move ahead here. Okay. I want to start where we left off earlier. I want to start with something called ASOP. Okay. This is something which I want to carry on from now onwards. Okay. We will talk about NumPy, we'll talk about Pandas, we'll talk about Matplotlib wherever there is a need. Okay. So because that becomes like very linear and will become very boring. Instead, I want you to focus on the fundamental libraries that you can code by yourself. Okay. And yeah. Okay. So essentially the where is my, why do I keep closing the things every minute? I just close everything. I think I got the disorder for closing things. Okay. Yeah. So this is the thing that I want you to discuss, right? Some part we already covered about it. Okay. And I want to walk you through this one. Okay. All right. Instead of opening from here, I have already checked out the code, and then I would be, where is that? Okay. This one. Okay. This is where I've checked out the code. Now, let's take a look. Okay. All right. So essentially, the whole idea about machine learning or AI is all about prediction. Okay. So we are trying to predict something each and every moment of our life. During World War, the army needed to predict the exact angle at which we need to throw the bomb so that it hits the destination, and predict the position where the when army somebody else is attacking you, you want to predict where it will hit so that you can save yourself. In the olden times, the civilizations needed to predict when will the river rise. Like, because of predicting when will the river rise, we came up with the idea called year. Year, Y-E-A-R, year is essentially an invention for predicting the rains. Not rains, but predicting the river overflows. Okay. And people figured out, like, so the entire of the science that we call science, if you look at it carefully, it's all about predicting for survival. Each and everything that you see. Even when we are walking, right, we are trying to predict at what angle should we swing, should we move our body, and at what pace, when to lift the left leg, when to, balance the right leg. So you basically are predicting each and everything every moment of time. As I'm speaking, I'm trying to predict next word to speak. Okay. So all of the algorithms, all of the people that are, and all of the science is all about predicting something. Okay. Each and everything, so we are predicting for survival. Of course, we survive in many ways. There are many mechanics for survival. One of the mechanics is we survive by reproduction. We survive by just a physical thing, just because our body is stable at the room temperature. That is one of the reasons of survival. And we basically survive by adaptation. We adjust or change given the surroundings. That's one way. We survive by reproduction, and we survive by prediction, right? Imagine that there is a, a jungle or a road, and there are two insects, right? And there's a stone rolling down the hill. First insect can predict that this stone will kill me, and it moves, and the second one does not. So the first one is more intelligent than the second one, right? So the definition of intelligence is all about predicting for survival, each and everything. If you think about all our vocabulary, take a look at all our vocabulary. How do we define good versus bad? Insect can predict that this stone will kill me, and it moves, and the second one does not. So the first one is more intelligent than the second one, right? So the definition of intelligence is all about predicting for survival, each and everything. If you think about all our vocabulary, take a look at all our vocabulary. How do we define good versus bad? Okay, things that are good for survival, we call them good. Things that are not good for survival, we call them bad. So every sentence of human communication, there is an implicit context called survival. Okay, when I say this person is doing good, okay, it means he's doing good for his survival. So in entire context, if you look closely, each and everything is around the survival. We have evolved, of course. We do not think of survival, but each and every part, like the definition of taste that you have, like this thing is tasty, this is not. Why? Because we needed shortcuts to define survival. This food, if something is not like the body has developed these shortcuts called taste, which kind of predicts the things that are good for us. Like for example, sugar. Sugar is good for us, and it was good for us when we were in the jungle. It may not be good for us now, but it was there. So each and everything that you see is around survival. Okay? Now, how does it matter to us, right? So when we define intelligence, we always define intelligence from the perspective of prediction for survival. Okay, when we compare two machines, two animals, who is more intelligent, we always compare them based on their ability to survive in diverse situations. Okay, so that's how we always, that's how we compare, and that's how we define intelligence. That's the primary definition of intelligence. Okay, this is important. This is context that I want to set, because people have, right? If you read, I read like probably 20 books on all kinds of AI and intelligence. Like for example, I was reading this book called Shadows of Mind by Roger Penrose. Okay, and even though I have a big respect for the book, but it did not really give a way of measuring or give a concrete definition of survival, a concrete definition of intelligence, because everybody has like very abstract definition of intelligence. Okay, for the context of the course, we will keep our definition very clear. Something that can predict well is more, it can predict for its survival, then it's really intelligent. If it is predicting for our survival, it is artificially intelligent. Okay, very simply. Okay, if it is right, like all the tools and machines that we're designing, they're not predicting for them, they're predicting for us, the people who are designing them, right? And that's why we call them artificial intelligent. Okay, now coming back to it, now this whole thing starts with like simple thing that we discussed in the beginning, that we are going to supermarket, we are trying to predict things. So we want to predict the next value, okay? And we discussed this part where we kind of framed it like an equation and we solved it. Everybody did it, right? This one. Then we did it for 3 variable equation. Okay, right. And then we were able to predict the value of things, value of the total cost, given the various numbers of mangoes and apples. Now, then we wrote the code for solving it using our Python code. And we made it such that we can solve any number of equations simply, correct? And we also discussed about the complexity. Then we also discussed about if we have to do the prediction for in non-linear manner, okay? So for that, we basically solve the quadratic equation, right? Everybody remembers this, or have you forgotten this? No?
Partially remember.
Okay, okay. So essentially, yeah, I think just go through this one. Okay.
I think we didn't do the quadratic, Sandeep. We only did solve the linear equation.
No, we did quadratic. I very well
Maybe
remember.
I missed the class then. Okay.
Okay. All right. So linear equations, everybody is clear, right? This way, right? Quadratic can be framed in the same way. Imagine that you are given the traffic at the time, right? So you have, I remember talking about this. So imagine that somebody told you that the traffic on the website grows up or down in a quadratic manner, okay? Not linear manner, okay? Now, you're given, let's say, the time at time 1, the traffic is 6, time 2, traffic was 12, time 3, traffic is 20. At 4, what will be the traffic? Okay, so we said, let's say traffic is equal to some constant multiplied by time square plus some constant multiplied by time plus c. Let's say this is the equation of traffic. For this equation, let's find out what is A, B, and C. We are given time and the traffic. So what we did, we filled in the value of time at time t equal to 1. So it became A plus B plus C, and traffic is 6. So A plus B plus C is 6. And then at time t equal to 2. So this became 4A plus 2B plus C equal to 12. And then we have 9 time equal to 3, 9A plus 3B plus C equal to 20. So we got 3 equations. Now we can use the above framed, whatever we framed above, we basically can do that, right? Using that, right? And that's about it. Using the solve equation, that method that we designed above, we can use that to solve these equations, and we get the A, B, and C. And now we can put it in our formula, and we can start predicting the traffic on the website, right? Make sense?
Yeah.
Okay. Perfect.
How can we assume that it is in quadratic? The traffic is moving in quadratic.
Yes. So that's a hard question. For now, let's assume that we are told by some senior that this data has been always quadratic. Okay, and that's it. So that's a kind of hidden knowledge. Or let's say you plotted the graph. Okay, first you try to assume that it is linear. That did not turn out to be great. Then you plotted it using quadratic. That seems to be more reasonable, and that's it. Okay, so you basically kind of assume that. Okay, and usually you do not know. You do not know whether it's quadratic, cubic, or fourth degree, or so on. Okay, so what you usually do is, first you try with the equation, say y equals to, right? We basically put it like this. Let's say you are given x and y. So you try with ax plus b, right? You basically, the general strategy is this, okay? Divide your data into test and train, okay? You are given some data and you basically divide, okay? 70% data points, I'll keep it for building the model and trying to figure out these coefficient A and B, and then remaining I'll do the test. Okay, so you divide it into test and train. Based on the train, you figure out the values of A and B. And then based on the test, you compare whether how much is the error in this model. Then you say, okay, let's try another one. We'll do ax square plus bx plus c. Do the same thing. Try to create this model and compute its error and compare between two who is better. Okay. Then what you do is you say, okay, ax cube plus bx square plus cx plus d. Okay. Now you try to calculate a, b, c, d this time and try to find which one, what is the performance of this on unseen data. And then you basically compare the performance of these three models and then you basically decide upon it. Okay. So that's a brute force method. And we will talk about this in much more detail. And this is how most of the people had done in past. Okay. But then neural network came in and neural network have the ability to figure out everything by itself. You don't need to keep doing this iteration about quadratic and all of that. Okay. All right. So now we have actually just
one question. Really? So where have you used ax cube plus bx square and all? I mean, in which type of prediction?
I mean, when the data is complex, data could be anything, right? So all I'm
Yes.
saying is, let's say we are given a problem statement, we don't know what kind of things fit into it. So we try linear, then it's quadratic, then cubic, and see which one is working well. That's
Okay.
all.
Okay.
Okay.
Got it.
Yeah. And there is no need of worrying too much because we have the computer with good GPU, and then we basically let the computer do the heavy lifting and not try to too much figure out by ourselves. Okay.
Okay.
And let it be. I mean, that's a general answer. Okay. Now, the other thing is, so far we only talked about curve fitting perfectly. What we talked about, that you are given two data points and there is a line fitting through them, predicts the third value. Okay, that's perfectly on the same line. Okay, that's what we talked about so far. Or we have a curve, okay, perfectly going through all these three, and we can have to predict the next value, right? Those are the two things that we did so far. Okay. This, right? What if the curve or line doesn't fit perfectly? This could be for multiple reasons. The data, the underlying relationship is fairly complex. There could be noise in the data. Okay. Imagine that there's a factory Okay, and this factory's input and output is like this. Input is 1, output is 8, input is 2, output is 11, input is 3, output is 16, and you have to predict that what will be the output when input is 4. Okay, so this is how our plot would look like. So we have used something called matplotlib.pyplot. So we have imported matplotlib.pyplot as PLT. We have given it a name PLT. Then we are saying pyplot.plot these 1, 3, 8, 15. This is different numbers actually, not this one, the one that we're talking about. Okay. This is the correct one. Okay. So we are saying plot.scatter 1, 2, 3, 8, 11, 16. Okay. So 1, 2, 3. Okay. Let me just hide this. Okay. All right. So these are the points. Okay. We can't fit a line through that straight. Okay. If you see, if you are joining and finding the line, either we can find this or we can find this, right? So these are two different lines. Okay. So what we want is, we want a line that is kind of going somewhere in midway, right? Are you with me?
Yeah.
Okay. How would we do that? Essentially, this is a case of approximation. We can't draw a straight line, but we are given this data and you will be asked, tell me what will be the value when x is 4. Okay, how much will that be? How would you calculate? Everyone, it's an open question. There is no single right answer. There could be multiple right answers. So now given these 3 data points, if I ask you, what will be the output when x is 4? How will you calculate? Everyone, it's an open question.
So if we don't want to use machine learning, right? What we can do is we can have slope between the 2 points, the first and the second and the first and third. And then we can say that the slope of the actual line will be between these 2 slopes. And based on that, get the line, and then wherever the line meets your x and y, that would be the value.
Okay, good approach. So you are saying we calculate
basically draw lines between, draw that line
slope
to the end.
Is this also?
No. I mean, draw this from A to B and draw A to C till the end, and then have a line between them, and that is your line, right? That is where you
will basically sum them up and then divide it by 3. Okay.
You don't need B plus, you don't, you need B and C as well, yes.
Okay. Okay, because the nomenclature could be anything, right? They could be like, we could be calling this as C and this is B and this is Okay, so okay, that's a good idea. Okay, but are you sure that this would work? Okay, so one is taking average slope. Good idea. Anybody else wants to add in, like, what could be your strategy to find out, given this kind of data, which is not perfectly fitting into a straight line or a curve? And please keep in mind that this data could be hundreds of points. Okay.
Yeah,
this data,
I would like to have a straight line which has almost like there is maximum number of points fitting into that.
Okay.
So I'll like each distance between that line. If I take distance of each points, it should be minimum like
Okay.
that.
How many points would you consider?
How many points? I
So,
don't know,
let's say here, these 3 points are, let's say, in a line, completely aligned. Okay. Rest of them are not aligned. Okay, rest of them are, let's say, not aligned. Okay. How many such combinations are possible? So you are saying that you will pick the line which has the maximum aligned data points.
Which
Perfectly.
should be closer to the all the endpoints. We can consider those.
Okay.
The mean value of the points, like the best fit of the, we can assume that linear equation mx plus c. So m is the one.
I mean, one approach is, but I don't know how programmatically or mathematically we can do, is that find a slope or find a line which is near to almost every point,
Okay.
closer to every point. But I don't know how programmatically we can do that.
Okay. Okay. Just think over it. Think over it. Let's see how can you do that. Okay. Can you brute force it? Yes, Sneha?
We can brute force by going from the lowest point, which means that we have to take one axis and then move from zero to traverse through that axis and get
Okay.
each point and then try to figure out whether it fits. I mean, first 2 point will give you a line. Then the second point will not fit in that line. So either you create your line from first to third point and see if the second point is closer to it, or you do first to second and then see the third point is closer to it. Whichever is closer,
Okay.
whichever is closer, then you take that and then do this, iterate it to the second point as well.
Okay. Okay. These are actually very wonderful ideas. I would want everybody to, think of your own ideas and think over it. And this is probably the time where you have to just think of out of the box, like what can I do with your own knowledge without studying, let's say, regression or any machine learning model, just first principle. What do you think and how would you do it? Okay. So you have some data, you're trying to figure out best, like you have to predict the y given x. Okay. That's all.
Can
That's
calculate the distance over here. So I mean, between the 2 points, whichever
okay.
is the closest, we can consider that.
Okay.
Yeah.
Okay. Think of it and can you scale it? So you can imagine that we are given all kinds of data, okay, and see if you can come up with those ideas. All right. So I would want everybody to think over it, and tomorrow we will continue from here. And this is the most critical part of the machine learning. I would want everybody to come up with those kind of ideas. Everyone, I'm happy that you have like genuinely your own ideas right now. I don't want you to become biased and instead of getting biased, just give more do more first principle thinking the way you are doing right now. Okay. Take time, sit down and try to figure out how would you do it, how would you code it, how would you code it. Okay. And
So
yeah.
Sandeep, do you have a data set for this? I mean, we can take a random data set, but it will be all over the place, right?
No. What you can do is say you take a little data set, right? I'll show you in this. I have generated the data set. Okay. Okay. Like here, I have generated the data set, you see? Okay. So what I've done is what I did was I have how did I generated the data somewhere. Okay, so what you can do is you can say, okay, right, you can say for x in range 0 to 100, okay, y equals to, let's say, 10 times x plus 20 plus, let's say, 0.5 times random. Okay.
Are you taking the discussion towards the importance of having temperature in predicting, Sandeep?
No.
I'm not sure, like, if I'm right in my
No,
prediction.
I want you to just do very simple thing. Okay. Take this data. Take this data. Okay. Take this data and I'll just append this. Okay. So okay. So this is my X array. That's my Y. I'll just append everything to XX dot append X, YY dot append Y. I just generated my data. Okay. And I'm saying, okay, it just became too good of one. I wanted it to scatter a little bit. 4x in, okay. Yeah, something like this. Okay. It doesn't look good.
It is because of the 10x. That is,
Yeah.
yeah. We'll have to maybe reduce it.
Yeah. Okay. Now it looks a little bit more random, right? Yeah, this looks more random. Okay. So we just generated the data. That's all. Okay. So task for everyone is to experiment with it. Okay. Experiment with it. And okay.
So can we use derivatives for this? Like,
Oh, what?
can we use derivatives for predicting the data
Okay.
points? Like
Yes. Think
comparing
of
the
it.
derivative with
Yes, do that. Do that. My only request is think of this problem. Think of this. This is the only problem in machine learning. Okay? That's the only problem that we solve by decision trees, by linear regression, by using the logistic regression. We use the what do you call the naive Bayes. We use the SVM. We use the neural network. Everything is around predicting the values. Even when we are talking about generative AI, generation is also prediction. Okay, so we'll talk about that much more. All right. So
Sandeep, how
that,
we can figure it out if we are accurate or close to accurate with our predictions or not actually?
yeah. So you take this data set, cut it into two half. Okay. Keep one
Yeah.
side, one part of the data set aside, and one part. Let's say you take this data set XX and YY and split it into two parts randomly, and just keep 20% data for testing and see which of the model is giving best results.
Yep.
Okay.
Okay. That's looking good. Actually, I was trying to, think in a way of stock market trading.
Yeah.
Actually,
Yeah.
if we are taking the, different data of a particular stock at different times and different days, in fact, and then, come up with certain logics which is close to accurate, then we can make heaps, right? Like we can even turn our fortunes actually.
Yeah.
Because that's most of the traders do on a daily basis actually.
See, what I want everybody to work upon is that just apply your own first principle thinking. Okay. All we are trying to do is we are given the past data, we have to predict the future, or we have to predict any of the things in between. Okay. So my request to all of you is that sit down and think about, like, the ideas that all of you gave in this class are just wonderful. You should cherish those ideas and work upon those. Okay. Because that's where that's what will get you into thinking, like, how would I do it? And when I explain it to you, and then you'll say, wow, that's something that I learned. Otherwise, if you do not do the first principle thinking, and I'm telling you, you'll just memorize it. Okay. When I tell you the algorithms, you'll just, oh, this is the only way. Okay. Don't think of it that way. Okay. Think of, be more like a first principle thinker. Sit down, think about, okay, can I do this? Can I do this? Can I do this? Can I do this? Okay. What if I do this? What if my data set looks like that? Would it work this way? So don't shy away from stupid ideas. Feel free to come up with crazy ideas. Okay. This would, maybe you won't invent a new algorithm, but I can guarantee the more you spend time thinking about it, the easier it will be for you to understand the entire flow, entire of the machine learning. Entire of the machine learning is simply this. Okay, exactly this. Okay, the x and y right now, it's a single scalar value. It'll become a vector, like 100 values in input and 100 values in output, and like the input might become an image, which is nothing but thousands, millions of input. X will become like millions of dimensions, and so on. So that basically the same graph will keep on becoming more and more complex. Rather than one dimension, there'll be million dimensions, and so on. Okay, so we'll yeah. So I want you to just think the way you guys are thinking right now. All right, we'll see you tomorrow at the same time. Have a good day.
Thank you. Bye-bye.
All right.
Thank you.
Spend good time, everyone.
Please check in. Sorry, just submit that in the GitHub so we can pick it up.
Okay. I'll do it right away before exiting. Okay.
Awesome. Thanks, Sandeep.
All right.
Thanks, Sandeep.
Python underscore, and then, okay, git status, and I'm saying git commit. Right. Yes. All right. I committed everything. So have a good day.